Hi, this is Gauri Shankar Rambatla presenting a OS project on RSA algorithm. What is RSA algorithm? It is a cryptographic algorithm. So what's cryptography? Cryptography is a method of storing and transmitting data in a particular form so that only those whom it is intended can read it and process it. The others cannot. So except for the receiver, the data is not in a readable format for the others. There are two main basic types of cryptographic systems. They are symmetric cryptographic systems and asymmetric cryptographic systems. What are symmetric cryptographic systems? These are the systems in which both the sender and receiver have a private key. What this key is that they both share the private key, but the disadvantage of this symmetric cryptographic system is that there must be a secure channel to share the key between the sender and the receiver. Now coming to asymmetric cryptographic systems, there are two keys in asymmetric cryptographic systems: the private key and public key. Private key and public key. Public key is known to all the nodes, and private key is within the node to decrypt the message. Now coming to RSA algorithm. What is RSA? RSA is Rivest-Shamir and Edelman algorithm, which is named after the inventors of this algorithm. It's a public key cryptography. That means it is an asymmetric cryptographic algorithm. It contains two keys, one public key visible to every node and the private key which is kept secret with the node itself. The private key helps in decrypting the message and the public key helps in encrypting the message. What are RSA algorithm operations? Now we have two keys. In these two keys, public key encrypt the messages and private key decrypts it. Now we see how it is done. I mean, how the message is uh, transferred to the ciphertext. What is ciphertext? Ciphertext is nothing but the encrypted message. That means the message in not in the readable format for the users is the ciphertext. Let's see operations of RSA algorithm. Here we consider two prime numbers P and Q. Now n is calculated. What is n? N here is the product of the two prime numbers P and Q. N is the modulus of the public key and the private keys. Now after finding the n, we have to find phi of n. Here what is phi of n? Phi of n is nothing but P minus 1 to Q minus 1. Why is this? This phi of n we use for encrypting the message. We see here phi of n is P minus 1 into Q minus 1. Next, the main part of the algorithm, that is finding the public key. Here public key is E. How to find E? We have to find E randomly, that is the number more than 1 and less than the phi of n which we find just now can be E. Then we have one more important condition for any number to become a public key. That is what is, it must be a coprime to phi of n. That is, it must not have greatest common divisor other than 1 with the phi of n. Now the obtained E, that is the public key, is released. It is released to every component. Now after getting the public key, our next target is to find the private key. How is it found? In RSA algorithm, we have an important formula. DE is equal to 1 mod phi of n. That is for d equal to 1 plus k phi of n. Here what is k? K is some integer. It can be any integer randomly. And now we see encrypting and decrypting the messages using an example. Let's assume that there are two guys, Bob and Alice. Bob want to send a message to Alice. That's a secret message. So we have to encrypt and decrypt the message. And now Alice gives her public key E to Bob and keeps her private key secret. Now Bob has to send the message M to Alice. He knows the public key E of Alice. So first what he has to do is he has to turn the message M into the ciphertext C. We already know that what is ciphertext C. Ciphertext is the unreadable format of the message. So we have formula for calculating the ciphertext. C is equal to message to the power public key mod n. This involves a lot of mathematical calculations, but this makes our RSA algorithm slow. But if we use exponentiation by squaring uh, the time for calculating the ciphertext reduces. So how is decrypting the message done? Now we got the ciphertext, that means we have encrypted the message. Now the message is safe. So how to decrypt the message? Alice can recover M from by using her private key. Here we know that RS algorithm mainly depends upon the key pair. I mean the private key and the public key pair. So Alice can recover M from by using from the message from the ciphertext using her private key D by the following procedure. Now message is equal to ciphertext to the power D mod n. Here we see that the formula for the ciphertext and the message seems to be similar. We have to be careful here. Now how did the decryption works and we got the original message M? It is because of the public and the private keys. Ciphertext to the power private key is nothing but message to the power public key to the power private key. How is this done? We know product of the keys is 1 mod p minus 1 or q minus 1. I mean the prime number which we chose randomly. By using the Fermat's little theorem for the prime numbers and the Chinese remainder theorem, we can conclude that message to the power ed is equal to message mod pq. Thus, ciphertext to the power public key is message mod n. Now, we see that by using examples, we chose two random prime numbers 3 and 11. Now we compute n. That's nothing but product of the prime numbers 3 star 11, that's 33. Now computing phi of n. This is nothing but p minus 1 star q minus 1. We got 20. Here the main thing starts. How do we calculate public key E? Public key is nothing but greater than 1 and less than phi of n. And the important thing here is that it must be co-prime to phi of n. So I chose 11. Here we can choose I chose 7. Here we can choose 11, etc., which is co-prime to 20 and more than 1. Now we got the public key E, so our next step is to calculate the private key D. How do we calculate the private key D? We already have a formula. D E is equal to 1 mod phi of n. So our solution is D is equal to 3. Here D is equal to 3, 3 into product of phi of n. So here we got the key pair public key public key 7 and the private key 3. So how does the encryption done? How do we find the ciphertext? We know ciphertext is equal to message to the power public key mod n. So we got ciphertext equal to 29. Here we have to be careful that our message is 2. So now after decryption we have to find the message, original message. So message is equal to ciphertext to the power private key mod n. We got 2. That is our matching our original text. Here we observe that the original text is not modified to the receiver, but it is modified in the channel such that it is unreadable by any others. Here we see some of the applications of the RS algorithm. RS algorithm is used in digital signatures. In coming to our daily life, we use ATM cards, e-commerce, etc. These all work on RS algorithm. Finally, how strong is RS algorithm is that till now there is no case recorded that uh, RS algorithm is break or hacked. Thank you. And here are my references. That is, I have adapted some data from these links. Thank you.